Continuing to review factoring polynomials. And tonight we'll be doing factor by grouping and splitting the middle, which is incorporated into factor by grouping. So by the end of this video, you should be able to factor using the greatest common factor and also factor a polynomial by grouping. Alright, today we're going to focus on, first of all, factoring a polynomial with a leading coefficient other than 1. So I know if I have a trinomial, I'm probably going to use my x. Now, this is only a graphic organizer for you to keep everything straight. You certainly do not have to use it. It just helps me keep everything where it's supposed to be. So the product that I'm looking for is a 2 times negative 21, which is negative 42. And the sum is the middle term, negative 1x. So I need a negative 1 for my sum. And the two numbers that satisfy that are 6 and negative 7. So now I'm going to take that 6 and negative 7 and split the middle term into those two. So I rewrite it as 2x squared minus 7x plus 6x minus 21. And now I'm going to do factor by grouping. Factor by grouping, if you have 4 terms in a polynomial, you pretty much know factor by grouping is going to be your best bet. So I look at the first two terms, 2x squared and negative 7x, and I notice that the greatest common factor of those terms is an x. So I'm going to factor out an x. 2x squared divided by x is 2x, and negative 7x divided by x is negative 7. Next, I look at my second group. I've got a positive x, 6x, and a negative 21. The greatest common factor of those is a positive 3. So I'm going to factor out a positive 3. 6x divided by positive 3 is a positive 2x. Negative 21 divided by positive 3 is a negative 7. And now, if I've been living right and being nice to Miss Pennington in class, I should have like terms remaining in the parentheses, and I do. So that becomes my factor, and I take it out of each group, leaving me with x and plus 3 for my second factor. So the factored form of 2x squared minus x minus 21 is 2x minus 7 and x plus 3. Right here again, we've got a leading coefficient other than 1. It's a 3. So I know I'm going to be using my graphic organizer here. And in the top part of my x, I'm going to put 3 times negative 8, which gives me negative 24. In the bottom part, I get negative 10. Now, two terms that multiply together to a product of negative 24, but a sum when added to negative 10. And I know that that's negative 12 and positive 2. So I take those two terms to split the middle term in my trinomial. So it becomes 3x squared minus 12x plus 2x minus 8. Okay, now we're going to factor by grouping. So we have 3x squared minus 12x. Greatest common factor is 3x, so we're going to take it out. And that leaves us with x minus 4. In my second group, 2x minus 8, the greatest common factor is a positive 2. We're going to divide both the terms by that. 2x divided by 2 is x. Negative 8 divided by 2 is negative 4. And I notice that I have a common factor of x minus 4 in each one. So I factor that out. And I'm left with 3x and positive 2. So the factored form of that trinomial we started with is these two factors. Okay, this polynomial, I start out with 4 terms to begin with, so I know I'm probably going to do factor by grouping. So I look at my first two terms, and I see if there's a common factor, and I notice that it's 3x to the second. So I'm going to divide both of those by 3x to the second. The first term becomes x, the second term becomes 2. In the second set of terms, the greatest common factor is 4. When I factor that out, I get x plus 2. And I noticed I have a factor of x plus 2 and a factor of x plus 2. So I have x plus 2, and then my leftover, 3x squared and positive 4, become my second factor. So there's the factored form of 3x cubed plus 6x squared plus 4x plus 8. Okay, this is another factor by grouping, and I'd like you to complete this one and bring it to class on Monday. Here's just a couple of hints to help you along the way. These should be in your handout. And here's our cartoon for our video today. And my shout out of this video goes to Amanda McGinty.